For part 2 of irrational numbers and square roots, we're going to talk about estimating the value of a square root. So we want to estimate the value of the square root of 28. The reason we are estimating it is because the square root of 28 is a non-perfect square. That means the actual answer is not a whole number, it is some sort of decimal. So we first want to round it to the nearest integer, which is the nearest positive or negative whole number. So if I think about it, I know that 1 squared is 1, and 2 squared is 4, and 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, etc. I know that the square root of 28 is somewhere between 25 and 36, so the answer has to be between 5 and 6. The question is, which one is it closer to? Well, 28 is closer to 25 because it's only 3 numbers away. It is 8 numbers away from 36. So if we were going to estimate that to the nearest whole number, it's approximately 5. So it's somewhere between 5 and 6, but closer to 5. Now we want to round it to the nearest tenth. That means we want to know, is it 5.1, 5.2, 5.3, etc. So what we do is we choose. So I'm going to pick 5.2. So I'm going to take 5.2, knowing that if it's a square root, when I times it by itself, I should get 28. So I'm going to multiply these together. 2 times 2 is 4, 2 times 5 is 10. Place holding 0. 5 times 2 is 10, carry the 1. 5 times 5 is 25, plus 1 is 26. Add those together, and I get 4, 0, 7, 2. So 4.2 is approximately 27.04. So that's less than 28. So I'm going to try the next one up because I want to get as close to 28 as possible. So now I'm going to do 5.3. I'm going to do the same thing. I'm going to multiply it by itself. 3 times 3 is 9. 3 times 5 is 15. Place holding 0. 5 times 3 is 15. Carry the 1. That gives me 26. 9, 10, carry the 1, gives me 28.09. So I definitely know it's either 5.2 or 5.3. 5.3 is too high. Oh, I'm sorry. 5.3 is 9 hundredths of a way, and 27.04 is 94 hundredths of a way. So it's closer to 5.3. 5.3 wins. Therefore, we estimate it to 5.3. Takes a little bit more work with math, but you'll get an exact answer. Let's look at the next one. We want to estimate the value of the square root of 38 to the nearest integer and to the nearest tenth. So we need integer and tenth. So if I go back to what I did on the previous slide, I took all my perfect squares, 1, 2, 3, 4, 5, 6, and I find what I got when I squared them. So 1 squared gave me 1, 2 squared was 4, 3 squared was 9, 4 squared was 16, 5 squared is 25, 6 squared is 36, 7 squared is 49. So I know that the square root of 38 has to be between 6 and 7 because it's between 36 and 49. It's closer to 36, so it's going to be somewhere close to 6. So I'm just going to estimate. I'm going to take 6.2 again. So 6.2 times 6.2, multiply 2 times 2 is 4, carry the 1. 2 times 6 is 12, plus 1 is 13. Add the place holding 0. 6 times 2 is 12, carry the 1. That gives me 37. Add them together, put in your decimal point, and you get 38.54. That's high, so we're going to go one lower than that. We're going to try 6.1. 6.1 times 6.1. 1 times 1 is 1. 1 times 6 is 6. Place holding 0. 6 times 1 is 6. 6 times 6 is 36. I get 1, 12, carry the 1, 7, and 3. So I have my choice. I have 38.54 or 37.21. Which one is closer to 38? The answer would be 38.54. So 6.2 is the closest tenth, and 6 is the closest integer. Now, let's define irrational numbers. If rational numbers are numbers that can be written as a fraction, irrational numbers, obviously, are numbers that cannot be written as a fraction. So they would be numbers such as pi, numbers that go on forever and ever, non-perfect squares. So they can't be written as a fraction. And we'll write some examples in there. We have pi, because it's 3.14, but that's an estimation. It goes on forever. Non-terminating decimals. And non-perfect squares, such as the square root of 38. So let's review what real numbers are. If you remember our concentric circles, real numbers are all sets of rational and irrational numbers. All the numbers you know are real numbers. There are imaginary numbers, but we haven't learned those yet. Now let's classify these as rational or irrational. So number one, if we look, we have 0.81, 811, 81111. So there are digits that are repeating, but are they repeating in a pattern is what you have to ask yourself. And if I look here, I have 0.81, but then I have 0.811, then I have 0.81111. So this is not repeating. It's non-terminating because of those three dots, so that makes it irrational. If I look at number 2, I can see that 81 has a line above it that is repeating, and we learned that repeating decimals are indeed rational. You can write them as fractions. 3 is obvious. Any number that can be written as a fraction is rational. And if I take the square root of 2, is that a perfect square? Will I get a whole number as an answer? No, it's in some kind of decimal between 1 and 4, closer to 1. So that's going to be irrational. Now, what have you learned? You should be able to identify terminating decimals, repeating decimals, non-terminating decimals, square roots, all of those good things. So in this lesson, we learned perfect squares, what they are. You should know what a square root is, so make sure you know the difference between those two. If I give you 11, 11 times 11 is 121. 121 is the perfect square. 11 is the square root of 121. Make sure you know those. You should also know how to estimate by finding which two perfect squares the number is between. And you should also be able to tell me the difference between irrational and rational, and be able to identify any number I give you as one or the other.